So I think it's taking time to, okay, it got connected, fine. Yes, so till now, let's have a quick revision of that previous one. So in real time, we have a problem and we need to find a solution to that. Problem. So relating the problem is one of the most important part. Once the problem is formulated, then we try to find out the solution. Okay, so for finding out the solution, we have different mechanisms, and in this case, if we see, if our chance you go to the next state, and therefore it was completely random in the first case. Secondly, we were having, okay, if you see random as it was a if I want to say it in terms of search, it was a random search we were doing, or a blind search we were doing. We did not have any idea that is going to help us. Yeah, let me just write it here. Yeah, so we had no idea in the first attempt. Okay, the first attempt we did. So we had that the random action is going to take us to the goal state or not. We had no idea about it. Okay, but in the second sim, you are going trying to identify the correct path, that how you can reach to the goal state, but you had no idea, no clue. But in the second case, if you see that we were calculating, again we were having random. The first step could have been random. Okay, the first step. But what we were doing, we were actually looking into the Q matrix, Q table, and looking into the Q table, we were trying to identify that which action is going to give us better results in terms of time and in terms of rewards. Okay, so that is something we were looking at. So here we had we call it as a heuristic. Okay, so a heuristic function we had, and this heuristic function was helping us out to decide, and we will call as informed search. Okay, and opposite to this was uninformed search, because we had no clue, no idea in the first case. And here normally we had taken, it was taking around 2000 plus time steps and penalties. Okay, so whatever 100 plus penalties we were to see. Okay, 600 penalties. Okay, so this was the case. And in case of after we did it with reinforcement learning, what happened? It was able to complete, like after 100 iterations. Okay, after 100, I'll say 100 in simple terms, 100 time learning. Okay, so after that, it was able to solve it in, I believe, 16 or 12. How much was that? Yeah, 12.67. Okay, so it was able to complete, I will round it off, 13 time steps. Now you can see the difference, like 13 time steps and 0.0 penalties. Okay, so this is what we were able to see. So both are a part of AI only. Okay, but you can see the kind of learning, the kind of learning mechanism the second one is having. It is very impactful. Okay. Now coming here to ontology, so this is completely very interesting and a different domain. Okay, ontology. So this
Kushal
comes
sir,
from, yes, yes.
yeah, yeah. Sorry to interrupt you. Actually, previously the screen was not changing. Right now it's okay. It's okay. Sorry, you can continue.
Okay, fine, fine. Yes. So ontology, this is coming from two Greek words. The first word is onto, and the second word is logia. Onto means existence or being real, and logia means science or study. So it has two meanings. One is philosophical meaning, another is non-philosophical, or you can say a scientific meaning. So let us try to understand both of. By reading it, you might have got an idea that philosophy also it relates to the different beliefs, okay, or you can say spiritual beliefs as well. Okay, so it is basically coming from there. So here you see that whatever is existing in the universe, it can be classified something like this: substance, and substance can be material, substance can be immaterial, and then the immaterial can have later on spirit. Then the can have a sub classification as body. Body can have sub classification as animate and inanimate. Inanimate will have all the minerals, and the animate will have living. Under living also we can have sensitive and insensitive. So plants are insensitive and animals come under sensitive. So you can see that how this whole classification is taking place. Okay, then animal can be rational and can be irrational. So the beasts are irrational, rational human beings are rational, and here also we can have different types of, okay, human beings. Now looking at this particular tree diagram, we are able to understand that philosophical approach of ontology, it talks about essential existence in the universe. Okay, and it tries to identify each and everything what is perceivable, few things may be non-perceivable. Okay, so whatever is perceivable, that has to be exhaustively classified the way you can see in the small tree diagram. Okay, so this is the philosophical approach of ontology. Now in case of computer science, it is again the similar approach we have here. So in case of computer science, we have a particular domain. The example domain could be, let's say, a bird. So the ontology says how you can represent this domain bird in in an organized manner. Okay, so that we call it as knowledge represented in formal way. The hierarchy of concepts within a domain. So it may be like bird. Bird can fly. Bird can um, there is a chirping of the bird. Okay, so whatever concepts are there associated with the bird. Bird can create a nest. Bird can lay eggs. Okay, so whatever concepts are related to bird, so we need to identify all those concepts, and we need to organize those concepts in a form of hierarchy. Okay, then second thing, a shared vocabulary to denote types. Okay, so there should be a vocabulary. Now we know languages, so it is easy for us to understand. So there should be vocabulary. Now this we are talking in terms of a computer to process these this vocabulary. Okay, then properties and interrelationships of those concepts. We will understand this by an example. Let's have some definitions from some different authors or different books. So yes, so one definition of ontology is that it is specification of a conceptualization that is designed for reuse across multiple applications. Now you can very easily correlate it, and it is not so different. Okay, let me take as of now to again Python notebook, and let me take hope the Python screen is visible. A notebook screen is visible. Yeah, is it visible? Notebook screen. Let me just check. share the link at the end of the session. Okay. Yes. Okay. Thank you. So let me take here new cells. Yes. So take it like, let me take further more new cells. Okay. So like in Python, if you want to create a class bird, so we have a concept of class and you can create a class bird. Okay. And within it, you can define, okay, certain attributes of the words, okay, bird, and they could be a function, fly, yeah, def chirrup0. So this is this can be another function. Okay. And if you want to initialize certain more things, so we have a constructor here in it. Yeah, here we can initialize self, and we can have, let's say color. Okay. And let's say we have um, wings. Okay, something like this. And then this pass I can remove, and self dot color, okay, equal to color, and self dot wings is equal to wings we have written. Okay. Yeah. So here if you see, I have got a mechanism of uh, I have a domain of birds, and I'm able to conceptualize this. Okay, how? By creating a class and then identifying some of its attributes, identifying some of its behaviors. I'm able to conceptualize this. Okay, so this is what here we are trying to say, that ontology is a specification of a conceptualization that is designed for reuse across multiple applications. By conceptualization, we mean a set of concepts, relations, objects, and constraints that define a semantic model of some domain of interest. Okay, fine. So this means I'm just comparing it with this as of now. Now I will create another class, and this class name I will be giving as, let me give it as Sparrow. Normally we give the first letter as capital. Okay, Sparrow. And now here I'm writing bird. So I'm showing a relationship between sparrow and bird. Okay, so this is a concept of inheritance in Python, that sparrow is a type of, is a kind of, or is a child class of bird. So sparrow is kind of bird. Okay, so sparrow is a bird. So this kind of relationship I'm creating by writing this way. Okay, and then I can have my own functions. Okay, own attributes. I can have sparrow's own attributes over here. Okay, maybe size is one of the attribute the sparrow is having, and self dot size is equal to size. Okay, so what I'm doing now, this can be reused. Okay, this is, I have written the specifications of the bird concept, and this can be reused for sub, okay, the child concepts I can say of the bird. Okay, or any other concept as well. Now, ontology is a specification of conceptualization in a sense that it is a formal encoding of concepts, relations, objects, and constraints within that semantic model. We'll understand this. Okay. One definition given by Passon in 2004: arrangement of kinds of things into types and categories with well-defined structure. Okay, so here it is explained that same kind of things you can organize it into the kind of hierarchy which we have seen here. Okay, same kind of similar kind of things. Okay, and the focus is put on, we need to give it a proper structure. Okay, there should be a standard structure to it. That is the emphasis which is put here. Okay, so let's move here. Now there is one more terminology which is called as knowledge base. Okay, so ontology and knowledge base, they are very much similar. There is a very thin line between them. Ontology is basically schema, okay, or it is basically the structure part. And as soon as, so here you can see that this is like a prototype, this is like a structure. Sparrow is also like a structure, but we don't have an actual sparrow over here. We don't have an actual bird here. So knowledge base includes the actual data also. Okay. So ontology, extension of ontology is knowledge base. Okay. So if I create a class sparrow, okay, so let's say SPR is equal to sparrow. Sorry. So okay, I did not execute the previous one. So let me just execute this. Okay. Yes. So here, if I create a class sparrow and I need to give size to it. So I will give size as let's say I'm not very sure, 9 is. I can give certain more things here. I can give color and wings also. So color I give gray, and wings I will give as, let's say, 2 wings are there. Okay. And here I can do super dot underscore underscore init init underscore underscore. I will pass the 2 other things. Okay, so C and W. So 2 other things I'll pass here, C and W. Okay, so again I'll, yes, so let me execute this. Some error I'm receiving super, but where super object. Okay, so yes, yes, I'm sorry. Okay. So this is, you can say, SPR is an object. So classes are your structures or schemas or blueprints, and this is actual object. So if I want, I can basically try to get all the things like SPR dot color we have, and then I can have is also there. Okay, so there's a function which does nothing as of now. Then we have wings it has got, and str dot, it has got a size also. So all these things. So gray is the color, 2 wings, and size is 9. Okay, so this actual data of this SPR. The actual data points or actual facts, we call them as, okay, they come under knowledge base. Okay, so let me just quickly read this for you. So here the domain which are in concepts of a domain, how the concepts related, and which attributes do they have. So here you can see. So let's, as per this, as per the domains of bird, we have a bird concept, sparrow concept, and we can have such n number of concepts. And then how these concepts are related. So here I have I have shown that sparrow is related to bird. Why? How that sparrow is related? So sparrow, which they have color wings attribute, and they have size attribute. So exactly this is what is shown by the class. Okay, let's more things. Now here, so in Google K graph you have certainly schema. Okay, so this is what is talking about schema part. Okay, and so here we see, okay, you certainly see schema like one described by DBpedia or Freebase. This you can go online and search, and a set of facts. Okay, now the set of facts are also available in case of knowledge base. Okay, so A relation B, Paris is a city. Okay, so Paris is a city. Now in our case, okay, I could have a class country. Okay, I could have a class this thing, maybe city. Okay, and then I could have actual objects created. So here if I say sparrow, SPR is a sparrow. Okay, because SPR is equal to sparrow. What does this mean? This means that SPR is a sparrow. Okay, it is of type sparrow. Okay, so A relation B. So Paris is A, relation is a, city is B. So Paris is a city. Paris has inhabitants 2M. Paris is capital of France. France is a country. So I believe you are able to get to know. So ontology is more of a structure. Okay. And knowledge base is structure plus the facts. Okay. We call them as facts because we need to represent them like one, entity 2, and how they are related. Okay. So this I will just show you, okay, which we will discuss in detail tomorrow. We will discuss that. So we have libraries for it. Okay, so one library I'm just demonstrating here. So we have a library called as rdflib. This library is used for creating ontologies. Okay, this rdf, this is basically this is how you can install it. This library is used for resource description framework. It tries to identify tries to identify from the whole set of data the valuable information and organizes it in the form of such facts. Okay, A relation B into such facts. Okay, so here I'm just showing you the example. So here you can see, okay, just try to observe this much. I'll explain you this. The highlighted one, just see this. So ns1 Cade. So Cade is somebody. Okay. Under that, if you see, under that, we have age 27, characteristic, kind, and married, NS1 marry. Okay. So here you can see that this library was able to identify it. I have manually added here. You can see. Okay, just observe this. I'll tell you in detail tomorrow. X.Cade, comma X.married, then X.marry. So Cade married Mary. Okay, this is the relation. Okay, so Cade and Mary. Okay, they have a relation, and the relation is Cade married Mary. So how this was actually taken out here? Cade, okay, and here married, and another entity Mary. Then Cade, its characteristic is kind. But in this case, we did not get 27 as a separate because we have taken it as a literal. So I'll explain you this tomorrow, okay, in detail, that how does this library works. So that's all for today, and let's continue tomorrow. Thank you. Yeah, so I'm done for the day. If there are any query or so we can discuss for some time, else we can conclude here.
Participants, if you have any queries or doubts, you can. Will warming. We'll see whether there will be any participants, right? Not will this. I think we can't say any queries or doubts because you have shared the information very well. Very nice session was very informative session was that, and thank you for conducting today's session. Tomorrow we'll meet morning with a new session. Thank you all. Thank you, Kushal sir.
Yeah, thank you. Thank you.
Yeah, participant, we have. I think ma'am has shared the link or the feedback in this chat box as well as on the WhatsApp group. If you don't receive this one, please email. I will send it on your email also. Yeah. So we'll conclude today's session. Take care. Bye.